Square rooting. We know the square root of a positive number is another number. We know the square root of a negative number is complex. But what is the square root of I being the imaginary unit? A lot of people might think we need another unit j. But what if I told you that we just needed an imaginary root and we can find the square root of any number? Let me show you how. So square root I can be written in the form a plus bi. Now since we don't like dealing with square roots, we can square both sides, and we get I is equal to a squared minus b squared plus 2abi. Now I can be rewritten as 0 plus 1i. From the right side of the equation, we know that a squared minus b squared is the real part, and so is 0. And again, we know that 2abi is the imaginary part, and so is 1i. So we can write equations a squared minus b squared is equal to 0, and 2abi is equal to 1i. From the first equation, we know that a squared is equal to b squared, therefore a is equal to b. And we can just substitute this into the second equation, and we get 2a squared I is equal to 1i. Dividing by I on both sides, we get 2a squared is equal to 1. Therefore, a squared is equal to 1/2. So, a is equal to 1 over square root 2, or root 2 over 2. Now, since we know that a is equal to b, we can just rewrite a plus bi as 1 over root 2 plus 1 over root 2i. And this is the square root of I. Now you might be thinking, well, looking at this, a squared is equal to 1/2, meaning a is equal to plus minus 1 over root 2. And you're correct. So this means that 1 over root 2 plus 1 over root 2i is not the only solution. Negative 1 over root 2 minus 1 over root 2i is also equal to square root of I. Therefore, both of these are the correct answer.